All right, so now we're going to solve radical equations. Radical equations, just like radical expressions, are equations that contain numbers or values contained under the radical symbol. We're mostly going to deal with squares and square roots, but it's possible for a radical to be a cubed root or a sixth root or all kinds of other funky roots. But we're just going to deal with square roots mostly. So if you look up here in the right hand corner, I've put a property down that if a equals b, then a squared equals b squared. So this seems a little bit obvious. If I were to write something, for example, 3 equals 3, then you ask yourself, does 3 squared equal 3 squared? Well, of course, because that would be 9 equals 9, and that's totally true. So the property seems obvious, but its uses, and as math gets more and more complicated, it can be a little bit tricky to work with. So you want to pay really close attention and develop the skills at this level so that you're ready for future algebra. So let's look at another way of applying this property so that it's more useful for us. Sometimes you're going to be given something like the square root of something you don't know. You don't know what the square root is of, but you do know that whatever it is, it equals 6. And this can be useful information written this way. In fact, you've probably already noticed, because it seems kind of logical, that, well, what would x have to be for the square root of x to equal 36? We expect, to equal 6, we expect x to be 36. But we want to be able to solve for this when it's not obvious. And what we can do is, just like we did here with the integers, if I square both sides, I'm confident that if I know that the square root of x equals 6, then x squared, or the square root of x squared would be the same thing as 6 squared. So square and square root, they're opposite operations, or they're inverse to each other, and so they cancel each other, leaving only a 6 on the left hand side, and 6 squared of course is 36. And we've shown using algebra what you suspected using your intellect. So let's just start right in with some examples and some practice problems. Let's start with example 1. 2 times the square root of x minus 8 equals 0. So you'll remember back not very long ago when we were dealing with the square root property, we had things very similar to this. They looked like, for example, 2x squared minus 8 equals 2. And what we did was we isolated the x squared. So first adding 8 to both sides, 2x squared equals 2 plus 8 is 10, and then dividing both sides by 2, so we get x squared equals 5. And then we would take the square root of both sides using the square root property and get x equals plus or minus the square root of 5, and then simplify or reduce from there. So in this case, we're going to do exactly the same thing, only instead of ending up with a square root, we're going to start with a square root and end up with just an x, just like here. We're going to start with the square root and end up with our x value. So let's go ahead and do that. I want to isolate the radical. So I'm going to add 8 to both sides. So 2 root x equals 8. Divide both sides by 2. And now, just like with the square root property, I don't really want you to square them, do this messiness here with the parentheses. It's just easier to learn it the right way in the first place, and then you don't have these bad habits, although these habits can be helpful for developing your skills. So if you feel you need to for the next bit of time, that's fine, but I'm going to show you the correct way. Well, if the square root of x equals 4, then I can square both sides and find out what x all by itself equals. So the square root of x squared, using the property, is just x. And 4 squared is 16. Notice I didn't use a plus or minus. That's kind of a mistake that gets made often, that students will want to put that plus or minus inside of there because it looks exactly like this property. But we don't really have to worry about that. The whole reason for doing this property is that there are two numbers that can be squared to give you, or let's work at it down here. There are two different numbers that you can square and get 5. The square root of 5 squared would give you 5, but minus the square root of 5, or negative square root 5 squared, would also give you 5. So you have to allow for both cases. But in this situation, we don't have to allow for two cases because it's already a radical. So we know that, because it's a radical and the operation that rids us of the radical is to square it, even if it happened that I had something negative here, it would be, which I wouldn't have an actual negative value there, but if somehow it were set up so there were an x value that would be negative, the act of squaring both sides, so the step that I didn't write down, which is to square x squared and to square 4, right? This act of squaring this automatically makes it positive. So we don't really have to worry about that step. We just say if I square x, the square root of x, I get an x, and if I square 4, I get 16, and that is my actual value. All right, so let me do one more example, and then you can go and practice a few. Let's do example 2. 3 root x minus 6 equals 0. All right, so again, I look and I see that I have a radical equation, and I want to isolate the radical by itself on one side of the equation. So that means I'm going to move everything else away. I'm going to start by adding 6 to both sides. So 3 root x equals 6, and then divide both sides by 3. So root x equals 6 divided by 3 is 2. Now I'm going to take the square root of both sides. So the square root of 3 squared, right, that's the same thing as writing the square root of 3. That is not true. I'm leading us astray. This is an x inside. So the square root of x equals 2 was the same thing as multiplying both sides or squaring both sides. So the square root of x squared just leaves me with an x. And on the other side, 2 squared leaves me with 4. And that's my one solution. So a couple problems to practice. So go ahead and do those real quick, and we'll look at the next case. All right, so let's look at this slightly more complicated version. Let's look at it from the perspective of, just like I did up here, where let's go ahead and put a little bubble around that. So there we go. So let's do a little memory bubble around another problem. In this case, I'm going to take 4 times x minus 7 squared plus 12 equals 28. Okay, now again, when we worked with the square root property, we knew to isolate whatever was squared. So that meant subtract 12 from both sides. What is that? 18, 16. And then divide both sides by 4. And then the square root property told us to take x minus 7 by taking the square root of both sides to get rid of this square. So x minus 7 equals the square root of 4, or plus or minus the square root of 4, which equals 2. Plus or minus 2. And then add 7 to both sides. So x equals plus or minus the square root of 2, does not, plus or minus 2 plus 7, and then you would chicken feed to get the two exact values. We're going to do the same thing. In fact, I'm going to do the same problem, only I'm going to write it up with a radical in the equation. So in this case, 4 times the square root of x minus 7 plus 12 equals 28. Again, subtract 12 from both sides. I get 4 times the square root of x minus 7 equals 16. Divide both sides by 4. Square root of x minus 7 equals 4. And isolated my radical, and everything else is on the other side of the equal sign. So now I'm just going to square both sides. So the square root of something squared just leaves me with whatever's inside. So x minus 7 equals equals 4 squared, which is 16. So x equals 16 plus 7, which is 23. And now you can do a quick check in your mind and just in your head. If 23 is my answer, if I were to plug in 23 for x, 23 take away 7 is 16. The square root of 16 is 4. 4 times 4 is 16, plus 28 is indeed 28. So it's clearly the correct solution. All right, so now let's do another example. This one has a little bit of a trick in it. So example 4. Okay, the square root of 6 minus x equals x. Okay, so what are we going to do here? The radical, meaning the square root part of the problem, is completely isolated already on one side of the equal sign, so we're just going to go straight to squaring both sides. But if I square this radical, then I just end up with what's left inside. So 6 minus x equals, I have to square this side too. Just to be safe, I'm going to write that step out just to make sure it's really clear. So I have 6 minus x equals x, or the square root of 6 minus x equals x. If I square this and square that, then I'm going to end up with what's left inside of the radical, 6 minus x equals x squared. Well, darn. What am I going to do with this? I have an x squared. No problem. This is just a quadratic polynomial. So let's get x squared on the left-hand side where I like it. And then I'm moving negative x to the opposite side, which would make it a positive x, and positive 6 to the opposite side, which would make it a negative 6. And all of that equals 0. Factor real quick. So I have x plus 3 times x minus 2 equals 0. So two solutions, x plus 3, kind of a sloppy use of chicken feet. Let me go ahead and make it right. X plus 3 equals 0, and the other factor would be x minus 2 equals 0. So x equals negative 3, and x equals a positive 2. All right, so now here's a problem though. We have two solutions, and you know when we have two solutions, you definitely know there might be an extraneous solution. There could be an extraneous solution when you have one. So we did a quick check in our mind to make sure that this was correct, but now that we have two solutions, we want to be a little bit more formal with the checking of them. So I'm going to go ahead and plug in x. I'm going to plug in x minus 3. Check that. So I have 6 minus negative 3 equals negative 3. Well, 6 plus 3 is the square root of 9 equals negative 3. The square root of 9 is 3 equals negative 3. That's clearly not a true statement. So this is not a solution. Let's check the other one. I have the square root of 6 minus 2 equals 2. Square root of 4 equals 2. This one's looking good. 2 equals 2. This is a solution. So in this case, my calculations gave me two solutions, but it doesn't necessarily mean that they're both actual solutions to the function. Or excuse me, to the equation. So let's give you a couple problems to practice on this idea. Okay, so practice those real quick. I'm going to give you a little bit of a hint. This number 4 is going to do something a little bit funky for you, but think it through. You have enough information and background knowledge to be able to know what to do there. All right, so last but not least, we're going to solve, what example number is that? Example 5. That make you a little bit dizzy? Sorry about that. So example 5, we're going to solve an equation that has radicals on both sides. So on one side of the equal sign I have the square root of 4x minus 12 equals the square root of x plus 3. Now at first you would look at that, I'm assuming, and go, what the what? I can't believe you're going to make me do that. But really, it's actually easier than it seems, because if I square both sides, right, so if I were to take 4x minus 12 and square that, I'm just going to be left with 4x minus 12. On the other side, if I take the square root of x plus 3 and I square that, I'm just going to end up with x plus 3. So this whole thing really reduces to 4x minus 12 equals x plus 3. Holy cow, you totally know what to do with that. You know so well what to do with that, you can even start doing more than one step in one part of the... I can say this. Watch me. I'm going to subtract x from both sides and add 12 to both sides at the same time. If I subtract x from this side, I'm left with 3x, and if I add 12 to both sides, I'm left with 15. Now divide by 3, x equals 5. Cool. That was pretty easy. All right, so maybe not easy, but certainly straightforward. But there is a case where they're not necessarily straightforward. Not really hard, but not really straightforward. So let's go ahead and look at that before we lose our nerve. All right, so we're going to take 2 minus the square root of x plus 1 equals the square root of x plus 3. Okay, all right, well, since I have a radical on both sides, I sort of have to do this step. Yep. On the left-hand side, the right-hand side, no big deal. I square this side, I'm just left with x plus 3. But on the other side, what's going to happen there? Well, I'm actually looking at a binomial. It's an ugly binomial, granted. But if I choose to square this side, I can't just square the 2 and then square the radical. That's not allowed, right? Remember, horrible things happen in the world. The Earth tilts off of its axis and global climate change occurs. So we can't just drop that square onto both sides across a negative. We have to actually distribute this as a binomial times a binomial. So 2 minus the square root of x plus 1 times, sorry, I got lost a little bit, 2 minus the square root of x plus 1. Okay, let's do the distribution. So first I'm going to distribute 2 to 2 and then 2 to the square root of x plus 1. So 2 times 2 is 4. 2 times negative root x plus 1 is going to be negative 2 times the root of x plus 1. And then I'm going to distribute the second term into both terms of the second number. Negative root x plus 2 times 2 would be minus 2 root x plus 2, x plus 1, and then minus root x plus 1 times minus root x plus 1. Well, a negative and a negative is a positive, and the square root of something squared is just whatever that thing was, so I can just take the x plus 1. All right, equals x plus 3. So I made it ugly. You might have made it a little bit easier if you had noticed that this was the square of a binomial, and you might not have had to do the distribution step, and you would have gotten this solution or this middle term already reduced to where I'm going to take you now. It doesn't matter. It's just one extra step. But at any case, you should end up with 4 take away 4 times x plus 1. Plus, we can go ahead and drop the parentheses by doing the distribution of a positive 1, getting just x plus 1 equals x plus 3. So it's already starting to look at least a little bit more manageable. 4 plus 1 equals 5. If I subtract that from both sides, then I would have a negative 5 over here. X is a positive x. If I subtract x from both sides, I'm going to subtract an x here. So if I clean that up, I have negative 4 root x plus 1 equals, well, the x's cancel. 3 minus 5 is a negative 2. So root x plus 1 equals negative 2 divided by negative 4 is positive 2 divided by 4, which is positive 1/2. Square both sides, so I get x plus 1 because the square root will disappear when I square this side. And on the other side, remember it's the property, square both sides. I can drop that into the numerator and the denominator. So 1 squared is 1, 2 squared is 4. And now, dun, da, 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 the very end we end up with x equals 1/4 minus 1, or negative 3/4. So that last problem was admittedly challenging at the Algebra 1 level, but certainly not beyond your ability to play with it or practice with it. We won't do a lot of problems like that at this level though. So let me give you a few problems. I'm going to give you 3. I'm going to give you 2 problems that look like this and 1 problem that looks like this for you to finish before you come to class next. All right, there you go. So the first 2, no big deal, straightforward. The last one can be a little bit tricky. You can make some decisions, and I'm going to let you decide. If I think about this side as having 2 square roots in it, it might be easier to just go ahead and square that side, right? So I have the square root of 5x plus 9 plus the square root of 5x times the square root of 5x plus 9 plus the square root of 5x, all equal to 9 squared. The advantage to this one is that even though it is admittedly horrifically ugly, you really can see that doing this distribution is just going to get rid of the radicals because I'm squaring the same thing. The same thing with this last distribution. So I can get rid of those radicals. And the only place where I have a little bit of ugliness, and I think less ugly than you think, is in the middle terms. So maybe try that. And of course the other option is to just subtract this radical, or one of them. I would choose this one. Subtract root 5x from 9 on this side, so minus root 5x, and then square both sides as we did in this problem. You make the choice. I just want you to practice one that looks like that so you have a little familiarity with them, and I'll see you in class.